Hello, my name is Manar, and today I'm going to be doing this op-amp circuit, and I'm going to be solving for V out using phasor domain. So what this problem asks us is to find Vi is equal to V0 cosine omega t, and we're going to evaluate it for V0 is equal to 2 volts. The angular frequency is 377 radians per second, and then we're given the values for our resistors and our capacitor. So first thing I'm going to do is I'm going to convert the capacitor to its impedance form using phasor domain. So we already know that the formula is negative J divided by omega C. C is the capacitor, and we're given the value, so it's just going to be negative J divided by 377 times 0.5 times 10 to the negative 6, because microfarads is 10 to the negative 6. And then I'm going to put that into my calculator. So I'm going to put it exactly how it is, and whenever I do my J, you have to go right here, and then you see that little I. That's what we're going to be using for J, because we can't put J. It's an imaginary number. And then divided by 377 times 0.5 times 10 to the negative 6. And I'm going to be putting all my numbers in rectangular form. And then whenever I get my answer, my final answer, I'll convert it to polar. So my answer is negative 5,305.04. And I'm going to put the J right there. Let me just make sure I'm recording. So I'm going to put the J in front. So now we have our capacitor impedance, and it's going to be in ohms. So I'm going to redraw the circuit, and I'm going to write down all the values just so it can give me some clarity. And V out. Okay. And then this right here, the non-inverting, is going to be connected to ground. So we already know this node right here is going to be equals to 0 volts. So let me move this down right here. So the capacitor is going to take this impedance, and it's going to be negative 0.04 ohms. And R2 is 10K ohms, and R1 is 2 kilo ohms. And then Vn, we already said that it was going to be, V0 is going to be 2 volts. So right here, we already said that this node, the voltage is going to be 0, and this node is the same as this node right here, which is Vp, and it's going to, they're both going to equal 0 since they both equal the same thing. It's all the same node right here. So Vn equals to Vp equals 0. So whenever we're doing our nodal analysis on this op-amp or KCL, we're going to account for this node to be, this node right here, to be 0. So this is how, what did I do? So this is how I'm going to do my, my KCL. So right here, Vn is equal to Vp, and then it's going to be going this way. So it's going to be Vp minus 2 volts is equal, divided by 2 kilo ohms. And then I'm going to go this way to V out. So it's going to be Vp minus V out divided by these two in series. So let's write it out. So we already know that Vp is going to be 0, so I'm going to just write out 0. So it's going to be this way, 2 volts divided by 2 kilo ohms plus Vp, which is 0, minus V out, all divided by the capacitor impedance plus 10, I'll write it out, 10,000. That's all in ohms, equals to 0. So 2 divided by 2,000 right here is going to equal to, I'm going to write it out on my calculator. So it's just negative 2 divided by 2,000. That's going to be negative 0.001 is equal to negative, actually, yeah, I'll move this over here so I can make V out positive. So it's going to be equal to V out over negative J305.4 plus 10,000. And then, and then I'll multiply this whole thing by the denominator of V out. 0.4 plus 10,000. So, I'm gonna write out in my calculator this times this, and I'll see what I get in my value. Times. Okay, and never forget your imaginary I, because that creates your value. So, now that I have my final answer, V out, so I get my answer in polar form, and this is how I want it to be, not rectangular form. And if you get your answer in rectangular form, but you want to change it to polar form, you're going to have to go to menu right here, and then you see where it says number, you're going to click on that. And then you're going to go to complex number tools all the way at the bottom. And then you're going to say, depending on what you want. So if you want to convert it to polar, you press 6. If you want to convert it to rectangular, you just press 7. But your final answer should be in polar, so you can get your angle. So my V out, my V out is going to be equal to 11.32, and we want this to be cosine, the angular is 377t, then the angle plus 152.05. This is all going to be in volts. So this is my final answer, and this is our V out in this circuit. So just to recap, we found our impedance for the capacitor, and then we redrew our circuit so we can test out all the values and get V out. And then we did a node voltage equation, and I did 0 minus 2, and this is 0 again because right here they're both the same node and it's connected to ground, so that means the voltage is 0. There's no voltage drop. So 0 minus 2 divided by 2,000, and then I went from VP to V out. So it's going to be 0 minus V out divided by these two in series. And then I get my V out to be 11.32. And then that's the form for it. So yeah, this is my equation and my steps to solving this problem. Thank you.